microphone.
yeah.
That's
Yeah, I
it.
can. Yeah, I can hear you now.
Right. Okay. Yeah. Yeah. The my system default sets to the internal stuff
Okay.
always. And actually, I use a separate webcam and that's got a microphone. Which is a microphone. Right. Okay. So hopefully everybody can hear me now. I'm John Davies. I have been a long time ago a spacecraft engineer, although I'm doing some of that sort of work now since I retired. But most of my career was in system software and systems consultancy, in particular in computer communications and latterly in mobile. So I did a lot of work and thinking in the early days, both hardware and software, about real-time systems, and that's something that I was mentioned in the remit that he's given us. So, am I speaking to prospective software engineers? Any of you? No. Yeah. Go ahead, Dino Tricks. You seem to be muted again. Gabriel stuck his hand up as well. I guess that means yes, you are heading in that direction, software engineering. Now, of course, that's an enormous area, and nobody knows all of it.
Excuse me.
Yes, go ahead.
I'm not really into software engineering, but I would like some insight on it. Maybe I can gain
Sorry,
some
I
info.
missed the second half of that. Could you speak perhaps a bit closer to the microphone?
Wait. I'd like to gain some insight on engineering. So.
Right. Well, I think the key point about software engineering is it is an engineering discipline. People talk about computer science, and that's an umbrella term that includes just about everything from logic and mathematics at the theoretical end of the spectrum, all the way to writing very, very low-level software that interacts directly with the hardware of a system. I'm more towards the hardware end of that in my experience. Although I'm interested in theoretical aspects of computer science as well. So I started off as an electronic engineer, and I worked in a space technology company in the late '60s in the UK. When we were still building big rockets, and which we haven't done for many years since then. So that's what I worked on. Mainly they were weapon systems, although one I worked on was the beginnings of a substantial space launcher, but it was cancelled, like a lot of things happened in the UK in those days.
So you basically started in the 60s, right?
Yeah, late '60s, '68 I graduated at Liverpool University.
So I was wondering, like, who inspired you to be in this field?
Well, I suppose there were a number of inspirations. Closest to home was my father, who was an engineer of a very nuts and bolts sort of type. If you understand that metaphor, he was a skilled tradesman, latterly working in the chemical industry. But he was a very capable and widely skilled engineer, and I took an interest in engineering to a large extent because of him initially. But then I started reading things. I right at the fictional end, I read a lot of science fiction, including boys' comics, basically, back in the '50s, and space had always fascinated me. But I was very much interested in the hardware and in electronics rather than in rocketry itself. Although again, I've taken some interest in that in more recent years. So I did a first degree in electronics at the University of Liverpool. I was the first person in my family to go to university, but that was not uncommon in those days. There was a great expansion of university teaching in that period in the UK and I think other countries too. And I got a job at a space technology company, which is now part of Airbus Defence and Space. And in fact, the same factory that I worked at is still one of the biggest builders of satellites in Europe. So that was my beginning. I detected that the momentum for that was failing in the UK and in Europe to some extent as well. And I started taking interest in particular in real-time software, and especially in communications software. And I spotted a job at the University of Edinburgh in the computer service of the university. I applied for that job and got it, and I moved to Edinburgh, and I was there 10 years, and I developed quite a lot of communications software, basically implementing communications protocols in both assembly language and in a real-time system language that we used at that time.
That's really wonderful.
Sorry, go ahead.
I was wondering, like, what type of basically, like, what do you really like about space? Like, what made you actually like space so much?
It was a combination of things. It was seeing what had been done in practice by German engineers, in particular weapons development, and in particular the V2 rocket, and what had been done in the UK, both in industry, where I ended up, and in advocacy, and in particular an organisation called the British Planetary Society, which is still in existence, was founded in the early 1930s by people like Arthur C. Clarke, who you may have heard of, and advocated space exploration and rocket technology and all the other technologies associated with that from a very early stage. And that began to accelerate while I was still quite in the early years of my school. And you could see that there was going to be, for example, there were going to be satellites in orbit fairly soon. I could detect that even from my very young perspective. And in fact, I had a conversation with my father, who was skeptical about space travel, and then of course Sputnik 1 went up in 1957, I think, actually. Anyway, at that point I would have been about 10 years old. And I'd been telling my father this sort of thing was going to happen in the future, although Sputnik itself was a bit of a surprise. And I think it's the first occasion on which my father conceded that I'd been right and he'd been wrong. It's most unusual for a child of that age. So I took that interest at that very early stage, and it's still there.
Yes,
Shall I
I'm
say
still
a bit
here.
more about? Sorry, yeah. Shall I say a bit more about the rest of my career? Would that be of interest?
So I was wondering, like, for example, if some students want to pursue that sort of career, especially in STEM fields, especially in technology and spacecraft engineering, like, what is the first step they should start in? Like, for example, for 10th graders or 9th graders.
Yeah, I mean, I think the thing to do is to take an interest in either the science or the technology or both, depending on which way your inclination is. If you're trying to find things out about the world and the universe, then if that's your motivation, then obviously science is the direction to take. If you want to make things work, build things, work with other people to build things, then clearly engineering is your direction. And there is a great deal of information around these days, which far more than was available in the 50s and 60s when I was younger. And
Like
it's quite
at the
easy.
time in the 50s and 60s, so people needed to read lots of books, lots of information, so they can just know more about space and more about everything.
Yes, indeed. Yeah.
Nowadays, you can just type to an AI, for example, like
Yeah,
Copilot
yeah.
or ChatGPT.
There's so much stuff either via AI or just by the web, and there are some even better books. If you just want to sit down and read a book and maybe take some notes, then that's a route you can take very easily now.
So
I even noticed
what do you want? Do you know tricks?
sorry, just a wee joke. I noticed a book called Rocket Science for Babies.
Really?
2 or 3 years ago,
Yeah.
which is not as ridiculous as it sounds. I mean, it's very much a picture book. It's very obviously intended to be humorous, but it does give you the basics. It's only about 20 pages long, and it's all pictures really. But obviously, you're a little bit older than that. At least the people in this school are. Yeah, so there's a whole spectrum of things.
It's okay if you can just. Do you know Trix wanted to say something?
Sorry, say again. Oh yeah, go ahead. Yeah, early design study for a space telescope. Yeah, that was interesting. That was what eventually became the Hubble telescope, which is still operational after all these years. What happened was quite early on, after I took my first job, I was working on the launch systems for a fairly large rocket called Bluestreak, and one day the boss asked me into his office and said, "We're doing a design study for a space telescope." And I said, "Oh, that sounds really interesting." He said, "Right, well, you're going to be the electronics guy on this team." And I said, "Okay." And I said, "I know next to nothing about the subject involved." He said, "Well, your job is to learn things yourself and to effectively pick the brains, use the expertise of all the other people in the company." And there was a great deal of it that I draw upon. So I pulled together the elements of electronics that were related to this study. What we produced was a space telescope design that was sized so that it would fit in a shuttle payload bay. The space shuttle was only just being thought about back then. This would have been around about 1970. But there were payload bay dimensions and payload mass. And there was an outline of what sort of things you'd be trying to achieve. So there was a team of 4 of us. There was a team leader who was an old hand in space technology. There was an optics specialist who looked at the actual telescope itself. And there was a dynamics guy guy with a PhD in this subject, who looked at how the spacecraft could be controlled, how it could be pointed very accurately at stars. And we came up with an outline design in a matter of 2 or 3 months. We presented it to European Space Research Organization in Paris. And recall, I was only about a year away from having just got my first degree. So it was just fortuitous, this. When I was there at the presentation, when we got to the ESRA headquarters in Paris, we discovered that there was a bunch of NASA people there, and we didn't realize that the relationship between ESRA and
Really?
and NASA
Were they astronauts?
No, engineers.
Oh, engineers, yeah.
Yeah, very definitely NASA engineers. Yes, I mean some of them may have had astronaut connections. Some of them may well have been people with active aerospace interests. They may have been former pilots. I didn't get to know them well. They were introduced, but from all that time ago, I don't recall the names. So we presented our design, and it was published. And I wrote a piece for British Interplanetary Society journal called Space Chronicle about this. And if you're interested, I can send you the PDF of the article. But basically, what it did was create a design that looked very like the Hubble as launched. It wasn't even called the Hubble then, of course. They named it much later, and it was only announced as Hubble about 10 years later, and I'd long moved on then. But it's remarkable how close the design that we developed, just an outline design, obviously, how close that was to the final Hubble as launched, which was actually 20 years later in the end. So that was quite a formative experience. And one of the things I do say to when I talk to schools is that's the sort of opportunity that you might well get in your very early career. And if you see something like that that's very advanced, that's going to enable you to really look way beyond the horizon in terms of development of the technology that you're interested in, grab it with both hands, because it gives you a perspective, it gives you a sense of what might be achieved during the period of your career, you know, something like 30 or 40 years of your career. And just doing it is inspirational personally, as well as being of possibly long-term interest. But as I say, I've written an article about that a couple of years ago for a BIS journal, and I can send that. If anybody's interested, I'm happy to send that along.
So, Dino wants to say something. Dino,
Yeah,
you can go ahead.
I'm seeing some of your question, but yeah, just go ahead and say.
Yeah, so hello, can you hear me?
Yes, I can hear you, yes.
Yeah, so over your decades of experience, what has surprised you the most about the evolution of space science and the public interest in space?
Let me think about that. Well, I got an initial surprise when Sputnik 1 went up, of course, although I was only 10 years old at the time. I was surprised at how fast things developed in the 70s, while I was actually doing something else. I'd moved on from the